Hello viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about combined charging system number 2. So let's dive right into it, CCS2. Now, what exactly is the problem that we have to develop something like combined charge standard number 2? Well, the reality is we need a standard way to charge every EV there is. Without it, we are lost. Now, to give you a context how lost we are is like, think of it this way. Let's say you go to a petrol pump and you do not see something like this. And every petrol pump has something different. For every car, there is something different. You'll be like, dude, it's not gonna work. And that's absolutely true. That's why we need a basically combined charge standard number 2. Because right now, there is no standardization in terms of basically vehicle charging. So you can have like basically AC charge standard, which is let's say type 1. Then you can have market type 2, then you can have GB/2, and then you can have basically speed charger of Tesla. Then you can have CCS number 1 charger, which is used in America. Then you can have CHAD mode, which is supposed to be DC fast charging. Then you can have CCS number 2, then you can have GB/T, and blah 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 blah. There are many more, by the way. Be mindful, these are just some popular ones. So that's the problem, and European Union kind of took the lead, and they realized very early on is that if there is no standardization, all EV will fail. It's not one EV that's gonna fail, or Tesla will fail, or Mahindra will fail, or Tata will fail. No, all of them will fail if there is no standard. Like, think of it this way, like imagine it this way, like your vehicle can only get petrol only in one specific spot. You're like, dude, I'm not gonna drive that. That's the same thing that's happening right now with basically EV. So European Union like went serious on it. It's like every Tom, Dick and Harry has to use CCS2 because compared to all of them, CCS2 is most thought out. Basically, it has taken care of almost every single problem there is. And that's why, like, if you are building an apartment and let's say you started to create a scenario where you have like, parking spot, each parking spot has like CCS2, that simply means every car can charge it there. And that's what people want to do at the end of the day. You do not want like, super fast hyper charging. If you have charging that can be done comfortably, where you rest your car basically in your garage or in a parking spot, done. We can have EV adoption today. That's why charging standard matters. Like, we cannot have lol on it. We have to go serious, and it has to be one standard to rule them all throughout the planet. Exactly how we have petrol law. Like this pipe that you see, Kamera, everything about it is like, measured, like how thick the metal should be, how much angle it should be, like what is the diameter, what is the flow rate, friction, everything is regulated. Only then this became this successful. Now let's understand the AC charging levels at this point in time. Now first thing you will have is AC charge level 1 charging, which simply means almost charging like how you charge a laptop. Consequence, it's very slow because you get that point, like you connect a plug to a socket, you're not getting too much amp out of it. You can have like, high load equipments, basically 15 amps in case of India. That is a lot because we have 220 volts. So 220 volts into 15 amps, that much power you can pump into equipment. That would be classified as AC level 1. Now AC level 1 is not a proper way of charging your car. That's a worst case scenario charging method. Basically, if you are stuck in a place where you do not have a charging infrastructure, you utilize this puppy, AC level 1, because it should work with everything else. Because generally AC level 1 chargings are so low amp, meaning if it's causing harm to your sockets or melting something like that, that means somebody else messed up, not you, not your car. That's why AC level 1 charging is basically lifeline kind of scenario. Basically, if you are stuck somewhere, you have no high current available to you, AC level 1 should get you back into the road over a very long period of time, meaning like around 8 to 9 hours will barely give you few kilometers, but that should be enough to give you some place where you have high speed charging. So AC level 1, that's the emergency worst case scenario option, barely good for let's say EV scooters, two-wheelers basically. Then you have level 2. Now level 2 is interesting simply because in case of USA it translates to 2-phase. In case of everywhere else it translates to 3-phase. That's why it's classified as level 2 multi-phase. Now kilowatt is directly limited by 2 core factors. Generally EV will decide what is the charging capacity, basically amps. We are talking about kilowatts here, so voltage is same because either you're gonna have 110 volt or you're gonna have 220 volts. So voltage is more or less the same, but amps change based on the cars, and what decides on the ampere is the chargers that are inside your car. Now be very mindful, these chargers are not the latest and greatest and not the most powerful one because they do have severe penalties. I'll explain that further, but generally this will say, hey, I can accept 50 kilowatts, let's say. Not 50 kilowatts, that's too goddamn high, but let's say it says, hey, give me 10 amps. Then it's gonna talk to your charge level 2 charger, and it's gonna like, hey, can you give me 20 amps? Charger may will have its own memory where somebody, if you had installed it correctly, will say, hey dude, do not draw more than 15 amps per phase. You can cause melting. So it's like, no, we can only go down to 15, basically up to 15. So this puppy will tone itself down to 15. But let's say what if inverts happen? Let's say this puppy is designed properly and it's like 15 amps, all three phases go you'll on it, and this puppy is only capable of drawing 5 amps. Again, this will just act like a socket. It will just give it 5 amps. Again, this is the drawing device, so it will limit itself. That's the limiting factor. And that's why even when you have lithium ion chemistry, which can easily have 1C charge rating, meaning no matter the size, you can charge it in 1 hour. That's what 1C means. 2C simply means you can charge it in 30 minutes. It does not matter the size. That's the chemistry based rating. So then why the heck we don't have EVs that can charge in 1 hour in our households? That's the problem. Is the charger that is on your vehicle itself, that takes the AC provided by level 2 receptacles, cannot convert it into very high current, so to say, to charge your systems, because they themselves are limited to very low ratings. Because this puppy is, let's say example is 3.51. generally cheap cars have that. This is a bit more oomfish, which can go upwards of 10 kilowatts of, and the highest I have seen is 22 kilowatts. Now you may be like, wait a minute, 20 kilowatts does not sound that much, because generally a battery bank can go as high as 30 to 90 kilowatt hour capacity. If 1C charge rating is there, then this puppy should be around 90. Now, while the reason they don't do that is because it's a dead weight, it's not doing anything while you are driving the car, so that creates an issue. So it also adds cost on it. Not only it's adding dead weight, it's also adding cost. This puppy is light and cheap. So if somebody is like, hey, I want a car that is cost effective to an Asian market, they're like, dude, I can only give you 3.5 kilowatt charging capacity. If you're like, dude, Tesla also gives you 2 options where you can have like 10 kilowatt charging capacity or 20 kilowatt charging capacity. So that's why AC charging is dependent on your vehicle. This puppy cannot do anything, because all it is just a fancy relay that turns it on or off, or technical term would be contactor. And all the IC and microcontroller you see there is basically just to negotiate. All it does is talk to your car and it's like, bro, I am the plug. I can give you 3-phase or 1-phase in case of some other scenarios, or even 2-phase in case of USA. It's like, this is my capacity. This is how much capable I am. How much you want to draw? Or basically draw below this. That's all it does, is basically draw below this. And what happens if the car starts to draw more for some reason, some fault, this will trip it. That's it. There is nothing more than that. This is just a plug that tells the receiving device what is my capacity. Other than that, there is nothing. So this has the benefit of not tripping your emergency circuit breakers. So that's all we have when we talk about AC level 1 and level 2 charging. And that's why AC chargings are never considered as fast charging, because it's always limited by this puppy. It's like, you can have a battery bank, you can have a AC scenario, because these are rated to very high levels. You can buy AC level 2 chargers that can pump upwards of, let's say, ludicrous power, like 50 kilowatts. Let's say your battery capacity is only 30 kilowatt. Can you charge it inside an hour? No, because your car's onboard charger may be the limiting factor. Generally, the lower one will decide what is the limiting factor. Most of the time, it's not basically your receptacle, it's generally the car's onboard charger, unless you paid for that high-end options. But even the high-end one only generally goes to 22 kilowatts. Some scenario, especially in buses, they may go higher, but then most of the time it will never cross 50 kilowatts, because again, it's a dead weight. You are adding this puppy to give one convenience, and you are causing 2 side effects. First, increased cost, and second, reduced range. That's why nobody wants to add this high capacity systems. Then we have to understand CCS2 properly, because CCS2 was designed with all the feedback from all the industry. So it has everything taken care of. And that's the whole part of CCS. Charge combined. What is combining? Basically, is combining AC charging and DC fast charging. That's the whole point. That's why it's called CCS. AC and DC. And because people realize that not every car needs GG 500 kilowatt charging rating. Not everybody needs it. Heck, only few car can even absorb 250 kilowatt. Not everybody needs it. So they designed it in multiple tiers. AC, it has 2 tiers, basically single phase or multi-phase, that you can decide, and each phase can draw upwards of 80, meaning this connector, cable, everything, if it's done properly, done to spec, not chipped out or not fake rating or China product, it should work to 80 amps. That should translate to 3 phases around 43 kilowatt, meaning if you have a good transformer that can provide that kind of power, this puppy should able to connect upwards of 43 kilowatt to your car. No car has as far as I have checked, that has like 43 kilowatt onboard charger as a default option. So this is more than good enough in terms of AC charging. Now that simply means you can easily slowly charge your car to around 5 to 6 hours. You can full charge it, meaning every night if you have this AC level 1 and level 2 charging, you're done. Overnight charging completely done, safe, don't think too much about it. Now there is DC level 1 charging. Now DC level 1 charging was designed for low end vehicles, meaning vehicles that do not require too much current or too much voltage. In those sort of scenario, it's going to use the same AC receptacle and it's going to classify as DC low requirement. DC low requirement has that same protective earth, that's the same earthing thing, contact pin and proximity pin. These basically these three things act as a primary data bus, so to say, and based on that it's going to negotiate. This thing is like almost like USB. How USB negotiates, because like you have a USB fast charging, you do not have a scenario where you plug an old mobile phone and fast charging is like 20 volts to an old mobile phone that can only accept 5 volts and goes boom. That because of negotiation, handshake, that's what's happening here. So it's gonna utilize CP pin and PP pins and protective earth to create a network where it's like what do you need, what is the voltage, what is the amps, like what do you need exactly. In those sort of scenario, it can decide to give, basically it's gonna change the relay inside itself and it's gonna give you DC plus and minus rather than AC. It's gonna give you DC plus and minus. Benefit of that is a DC level 1 low requirement that can give you around 28 kilowatt. Now 28 kilowatt capacity is more than good enough for low end cars, and actually two-wheelers, almost no two-wheelers can exceed this puppy. But in case let's say you want even more oomph out of it, or your amp draw is a bit too high for some reason, let's say your voltage pack, let's say for safety reason you wanted your battery voltage to be low as like 48 volts, so it's human safe. Okay, you got the voltage safe, it's human safe, awesome, but amp requirement went up. At that point in time, maybe you exceed the amp rating 70 amps, you may require more amps. So they're like, dude, we still have more pins, so it will gang up 2 more pins, so 4 pins will be there that will act as a like combined 2 pins, meaning 2 positives, 2 negative, and you can go combined amp rating of 140 amps. That translates to 56 kilowatt of energy transfer from point A to point B. That's a lot. And that's why I genuinely hate every goddamn EV manufacturer that's building two-wheelers in India. It's like, this is why CCS2 was built. It solved all your problems. And they're like, no, we had to build our custom so we can have DC fast charging. It's like, dude, that puppy has 28 kilowatt as the cheapest option. That's like a DC low. That's how it's legally classified. DC low. DC mid goes to around 56, and DC high, that is like DC level 2 charging, that goes around 100 kilowatt. So why exactly did they created a new e-waste scenario? And be mindful, this puppy is used everywhere. Even CCS1 is more or less backwards compatible with this whole idea, and CCS2 is used in Europe, China, everywhere else. Every future manufacturer is utilizing that. So the fact that all two-wheelers is not utilizing this amazing feature of DC low rating is kind of frustrating to me. It's like, dude, just use that. And again, you don't have to buy that expensive plug. Yes, it is expensive. That female receptor is expensive. The connectors, they are expensive. But again, these things are cheap. That's why they built that. Like, if you do not need too much amp, why the heck you want to use GG amounts of thick cable? But this is like 28 kilowatts and 56 kilowatt. Okay, you got that. But what if you need more? What if you want super duper fast charging? What if you want to go to 100 kilowatt charging? At that point in time, you go to level 2 of DC. These are level 1, this is level 2. Then you're gonna use that 2 thick boy cable. Again, this will not have all the other pins. Basically 4 pins will be removed. It's still gonna have protective earth, it's still gonna have contact pin, it's still gonna have proximity pin, and DC plus and minus. And this puppy can dump upwards of 100 kilowatt uncooled. Now be very mindful, engineers did try to increase the capacity, but problem was once you go up in basically voltage is kind of limited, because these systems are generally rated to 500 volts less, meaning you have to be below 500 volts. Most cars are around 450, so it's more than good enough for that. But consequence, the amps go YOLO. So amps, again, can you make a cable that can support more amps? Absolutely. Problem was no human was able to yield it, meaning you can't have like it was too difficult. People tried to do that, but it was like it was unbearable, meaning people want this petrol pump experience, which is like, again, petrol pump pipe is not super easy, but like you get the idea. Like that's what people want, is like, I can do it. It should not require like I have to do 6-hour gym just so I can move the goddamn cable. So the cable had a copper limitation, meaning it cannot use very thick copper bus. So they are like, okay, we can do reduce the copper. Then how the heck you carry hundreds of amp, meaning this puppy can go around 200 amps. How the heck you do that? You add cooling to this, meaning if you are going any charging standard that is using CCS2 and has very high capacity, even any DC fast charging, that is DC level 2 charging above 100 kilowatt, generally they will have liquid cooling into it. The pipe will basically have a coolant channel for it. Now again, generally coolants are basically oil, and without it, it will simply not work. The cable either will become too goddamn fat or it will melt too quickly. So they had to use that. Now, how much can you do if you are cooling it? 500 kilowatts. That's why I specified whoever built CCS2 learned from everything. 500 kilowatt is so goddamn much that you can charge a bus. So that's why CCS2 is like, it is slowly becoming de facto industry standard, and it has all the reasons for it. It's not just like, oh, somebody forcing it. No, it is like properly designed, properly calibrated, and it has like a lot of options. You have AC phase 1, you have AC phase 2, you have DC 28 kilowatt, you have DC 56 kilowatt, you have DC YOLO amounts of kilowatts, around 100 and to 500 kilowatt if you have the cooling option. Again, I'm pretty sure 100 kilowatt will not be achievable in India, because every white paper I'm reading is saying 21 degrees Celsius outdoor temperature. I'm like, India has 51 degrees Celsius outdoor temperature, so I'm pretty sure that 100 will also require cooling, but you get the point. Like, it is inbuilt into the system. If it's 2 spec, what we call 2 spec, you should not have to worry too much about it. So that's CCS2. That's the amazing aspect of basically learned from every other's mistake, and then they created this puppy. Now, DC fast charging is very complex, simply because the AC to DC that is happening, you are no longer providing a plug, you are providing the DC voltage bus. It has to be done outside. Now, benefit, it matches the DC voltage of the main battery bus. It directly matches it. So if your battery bank is, let's say, 150 volts, it's gonna give 150 volt DC. If it's 400 volt, it's gonna give 400. Basically, it will do as much as matching as it can do, as long as it's below 500. 500 is the CCS2 limit. Again, some people are working on making it 800 volts, but right now there is nothing that actually needs that kind of ludicrous power. Now, how much amp this puppy can transfer? At this point, the spec is very capable. If it's cooled cable, the spec is like, dude, I got this. Cable is not the limitation, plug is not the limitation, everything like that is like taken care of. It's just like who can provide and who can consume. So at that point in time, your car will ask, hey, give me this much. And this is one thing you have to understand about lithium chemistry. It can charge at very high C ratings, meaning C1 translates to 1 hour full charging from 0 to 100. Now, a lithium ion, if it's drawn down to 0 level, you will slowly charge it up, meaning basically you will let it warm, the cell chemistry to warm up a bit. So you'll let's say in case of a Tesla battery, you will be like, hey, just take 50 kilowatts, you start to warm it up, then you detect the cell temperatures have reached that optimum level, then you're like, okay, now you go YOLO on it, now you can dump 200 plus kilowatt into it, and then you will do that until it starts to reach 50%, then you'll tone it down to 100, then once it starts to reach 80%, you will tone it down to very slow limit. And that's the problem. That's why like we rarely get supercharging, that's like charging inside an hour, because 80% you can do that in 50 minutes. That's not even 15 minutes is doable if you really want to cook your battery, and if you have good cooling system. And I'm talking battery cooling system, not the cable cooling system. If you have the battery cooling system, 50% charge in around 20 minutes is doable easily. Consequence is that after 80%, lithium ion really does not like to eat charge. It's like, dude, I'm full. It does not like to eat charge. At that point in time, you have to slow it down to its level. For longevity's sake, you can force it, but by your lifespan. So that's why that is a chemistry level limit. Now, is there a way to bypass that? If you really want a safe way to get like, full capacity in like, let's say 3C rating, which translates to around 15-minute charging time, yes, you have to use lithium titanate cell. Why don't we use it? Again, China does use it for buses. Consequence of that puppy is that it's not very high capacity system, meaning if you have the same car, same basically weight, same liters in terms of volume, it will reduce like around, let's say if it was 400 kilometer range, it will go down to, let's say, 300. That's why people don't use it, and range anxiety is the biggest issue, so people don't tolerate that. Again, it does have a lot of other benefits, because it does not have too much capacity, people don't use it. Some car company did try to make hypercar using that, because it does have ludicrously high amp capacity, meaning you can charge that puppy in minutes, 2-3 minutes. I'm talking basically faster than electric basically fuel pumps. So that's the hot part. And now there is another problem, is like, if you go to any electrical provider and it's like, hey, give me something that can give you high voltage DC, they're like, okay, it's expensive, but we can do that. You open your mouth and say, give me that can do 200 amps or 400 amps, they're like, yeah, that's the door, disappear. Or bring bank, Bill Gates level bank balance. So what Tesla did was very clever. It's like they had already 11 kilowatt systems and extended 20 kilowatt system. They just stacked this. DC stacking is surprisingly easy, especially if you match the positive negative and voltage level is stable. You can just add as many amp as you can. So that's how they can achieve that, 100 kilowatt, 200 kilowatts, 250 kilowatts. That's how they are achieving it. They are just stacking as much as they need. And that's how like even they divide it. Like every charging spot that you say, they generally have like a few of these and a lot of receptacles. So if a lot of receptacles are populated, it will divide it. And that's another benefit of that. Utilizing this basically modular approach, they can divide this, like, give 3 chargers to this puppy, 3 chargers to this, 3 to this. And it's like, this is about 0% charge, like, give 6 chargers to this puppy, so you can fast charge it very quickly. And then you're like, okay, now you go to slow slow, now you go to this. That's how they do it. Even if you buy, this is from Tesla, but again, even if you buy someone else DC level 2 charging, generally they will have multiple modules. This also has the benefit of, if one fails, your system does not go down. Again, charging speed will go down, but you will be safe, you will still have charge. So that's the easiest way of doing it from cost point of view. That's what I really like, that idea. It's like, we are already manufacturing this for the cars, why not just use this into stacking and then make it into supercharger. But be very mindful, the moment you start to reach that 200 amp, you have to have liquid cooling. So whenever you are seeing CCS standard that can go 350 kilowatt, there's a lot of cooling into there, going into there. So what we can expect in the future? Well, right now I'm assuming, not assuming as in like I'm studying the market, I'm noticing people are trying to go to 10 kilowatt charger unit on the cars, because once you have that, then you have perfect overnight charging, and that's the end game. Meaning, if you at the night when you come home and before you wake up and go to drive your car again, it should completely charge from 0 to 100%. Most of the time, even low capacity chargers as in like 3 kilowatt charger will do that. It's like, I got this. But like 10 kilowatt has more than enough spare range where it's like, dude, I got this. Meaning 0 to 80 it can do at full capacity, and then it is gonna slow down. It's like, okay, cell capacity, take your time, we have the lifespan to deal with that. However, one thing I'm noticing, for some reason, again, I could be wrong into this, but some reason they are not using the main motor driver as the charger. Motor driver is the highest capacity unit in any electric vehicle, man. That has the horsepower, and if you translate the horsepower to kilowatt, that's a lot of kilowatts. So why the heck they are not using as a charging mode? And you may be like, okay, the energy cannot flow backwards from basically invert a motor driver unit to the battery. No, it does. That's how regenerative braking works. And most motors are generally 3-phase. It does not matter it's BLDC or does not matter it's AC induction. It generally have 3 conductors going there and 3-phase. So I'm pretty sure it can be done, and I have seen something like this done in different kind of environments, but I have not seen some company figuring out like, hey, what if I add basically switching block. Again, you have to switch the cables, switching block, and then directly have AC high phase, basically high amp current directly going to the motor controller, and then motor controller feeding to the battery, because it already knows how to do that. It's just AC part that has to be sorted. Again, if somebody can do that, it will add electrical complexity undeniably. So it does have to do phase matching. Basically, it has to do reverse of chopping. Basically, it chops DC, makes it into AC. It has to do invert of that. It can be done. It has been done. It's just like it will add electrical complexity undeniably. So however, it will add range, and it will add the relaxation where it's like, you can have 20 amps 3-phase charging, which can charge even a very high capacity basically 90 kilowatt hour capacity EVs very fast. And the benefit of that, AC chargers are far cheaper than DC chargers. Far cheaper. It's like, one is costing barely $2,000, one is $20,000. You get that point. Like, say, it's much more efficient, much more practical to populate it everywhere. So that's one thing that I'm noticing that can be done. I know from a physics point of view, from engineering point of view, it can be done. But if you know any exact reason why you can't just have disconnect the, again, contactors that are capable of handling the motor currents, have a contactor, disconnect it, reconnect it to the AC line, then directly feed the system. Again, it does have to do phase matching. It will require a different level of microcontroller processing, but it should be doable. It should be doable. Because it has the benefit of, while you are adding electrical complexity, you are increasing the range, because you no longer have that goddamn charger unit. You're just like taking that unit. That's awesome. And not to mention, the higher amp capacity of AC line simply means you can charge everywhere. Everywhere you have 3-phase, you can charge at very high capacity. Again, it will still not match the DC ultra high charging capacity, but it will be more than good enough for most enough scenario. At that point, people will be like, half an hour charging for most of the capacity. That would be awesome. So that's one thing that I personally want to see in the market in the future. And I genuinely want CCS2 to become something like this, where you just have a charging station. You don't think about what plug it has. It's just a charging station. You just twink, done, go home, sweet dreams. So this was my presentation on CCS2. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.